Alright, so with your 3-2, first of all, you probably still have a few questions, I would imagine, on 3-1. Okay. So what I will tell you guys is, in my personal opinion, after the lesson, go through. If you have questions about 3-1, ask your questions about 3-1, and then attempt to do one question in 3-2. And what I would recommend is doing one of the end problems. So I know that some of you guys like to go in numerical order and start with number 1. Number 1 is probably easier than the other ones. So I would start off with one of them that has like the ladder falling down the side of the wall. I would start with one of those. That's where I would start and work your way backwards instead of working your way forward. You will have a homework quiz tomorrow. It will be on 3-1 and 3-2. Mr. Blanco will be your guys' son tomorrow because I will be at the zoo with my daughter all day.
Yay! What a group! So much fun.
I'm like, I texted Mr. Blanco this morning to make sure we were okay. I said, can I send you to the zoo instead? And I'll stay here. No, I like going to the zoo, but it's just, I know that I'll have other children other than my own that I'm responsible for.
Your epic that can make you out of it.
I know, right?
It's the same thing as here.
Is there like
Yeah, but like when it comes to, I have no problem with disciplining my daughter, but I feel we are disciplining other people's children.
bad?
I try not to. So I'm hoping that her best friend, either mom or dad, is going to on the field trip. So I'm like, can we hang out together? Can our groups merge together?
We buy over rice food.
Oh no, they're not allowed. So they're not allowed to. They're not, and it makes sense. They're not allowed to have anything but a sack lunch, either provided by the school or provided by me. But the sack lunch, everything in there has to be able to be thrown away. So what I'm gonna do is I'm gonna have like all of her little snacks with her sack lunch, and then I'm just gonna bring her own. She likes cup of noodle for lunch, so I'm gonna bring the cup of noodle myself for her. But we're not allowed to pay for feeding the giraffes, and we're not allowed to pay for feeding the stingrays. Because they want to create an equal experience for all kids. And if some of the parents don't buy in for all the kids, then it's not fair. It could have been me and my daughter's best friend's dad that messed that up for everybody last year, because we paid for the giraffes, we paid for feeding the stingrays, because that was the first time my daughter's ever felt the courage to actually feed the stingrays. But we did it all, and apparently that was frowned upon. I just thought that was the thing to do. I don't care. I'll pay for somebody else's kid. It doesn't bother me.
Why are we? I don't want to be here.
I wanted them to experience it. So, I think we've fed the stingrays twice, and we did the giraffes once. That's the whole reason why, you go to the zoo is to be able to do the feeding. So, I wish they would have just charged more to go to the zoo, like the voluntary donation. I wish they would have just charged more and then just included the feeding. It's $2 for the stingrays. Yeah, I think the giraffes is $5 or something like that. And if it's your birthday, you get an extra piece of lettuce. Just saying, we have to go to the zoo on everybody's birthday because everybody gets an extra piece of lettuce.
Yeah!
And the birthday pin. Alright, so let's look at your 3-2. I know, math time. No more story time, math time.
Sorry, video.
I know, right? Sorry, video. It's okay. Everybody else can be privileged to the story time. Okay, so when we look at 3-2, 3-2 follows from 3-1. So 3-1 is implicit differentiation, where every single time you take the derivative of y, you write dy dx. The reason why you do that, or one of the reasons why you do that, is because x is the independent variable. So anytime you take the derivative of the dependent variable, like y, you have to write dy dx, because it tells you that you took the derivative of y with respect to x. The issue comes up with related rates, which is this particular section. This section is called related rates because it is relating rates of change. Relating rates of change means that you're relating derivatives to each other. So, rates of change represent the derivative. We are going to look at time now being your independent variable, which means that your dx, or your x, when I take the derivative of x, he's now going to get a dx dt. Your y's are going to get dy dt's, because now your independent variable is no longer x, it's time. You can thank physics for this. It's all physics fault. Yes, Alex.
Oh, it's not that though. We just take derivative instead of just doing y. But instead of doing dy dx with y, we do that.
Correct. Yeah. So all it means is that everybody gets a variable.
Yeah.
So here, if I have, and this is the easy one, if I take the derivative and I have a x and y are both differentiable functions of t, that means that t is your independent variable. So dy dt, because that will be the derivative of y, which is 1, dy dt, is equal to the derivative of x, which is 2x, dx dt, and then the derivative of 3 is just 0. Okay, and then everybody gets plugged in. So dy dt is equal to 2 times x is equal to 1, and dx dt is equal to 2. So you get 4. So, step 1 is to always find an equation that relates all of your variables together. Step 2 is to take the derivative implicitly with respect to time. Step 3 is to plug everything in. Don't go out of order and start getting plug-in happy and start plugging everything in and being like, oh look, I got 0. No. Like, because if you plug in all your numbers first and then you take the derivative, you're going to get nothing. So always, always find an equation first, take the derivative second, and then plug everything in. Okay? As you start to look at 3-1, and then you start to look at 3-2, and then once you see your homework quiz tomorrow, I think you guys can see how I could very easily make a free response test out of this. Something else to be aware of, because I did not change it up on the board. No, it doesn't matter. The board is not changed to there. On your calendar, I need to change it. I'm not going to do 3-3 on Monday. We're going to do 3-4. I'm going to skip 3-3 because 3-3 is a multiple choice topic, not a free response one. We're going to do 3-4 over 2 days, 3-5 over 2 days. Do a review day before you guys do your quiz, and I'll do 3-3 along with inverse derivatives, inverse function derivatives, that question 19 on your quiz. I will do that before you guys take your midterm. Okay. The reason why I'm doing that is because when I looked at what I did with BC yesterday for 3-5, they all went, huh? And then I actually had like about 3 or 4 remind message questions from them yesterday, which led me to think that we should do 3-4 over 2 days and 3-5 over 2 days to give you guys a chance to get the lesson done and also to give you an extra day to get the work done and then give you guys a day for review for your quiz. So I spaced it out a little bit, moved the 3-3 to the root to after, you know, to when the midterms.
I think you pretty much does it for like your response.
You will. No, there's no question whatsoever. The free response is really, really nice in general. Because the way with the free response is that I can give you guys 8 topics and tell you 5 of those topics are probably going to be on your free response test for the AP. I cannot predict at all what's going to happen on multiple choice. With the free response, if I can give you probably about 8 to 9 different topics and guarantee that 5 of them will show up. And guarantee for sure that 1 of them will show up, so much so that if you turn in your test without doing this one process, I know you screwed up and you should know you screwed up too. Because it shows up every single year.
Oh,
So,
that's
separation of variables shows up every single year. Okay, so a pebble is dropped into a calm pond, causing ripples that form concentric circles. The radius of the outer ripple is at a constant rate of 1 foot per second. The radius is 4 feet, at which rate is the total area of the disturbed water changing. So, circular. So, area formula for a circle, pi r squared. That's step 1. Step 2 is to take the derivative implicitly. So, dA dt is equal to pi times 2r dr dt. Most commonly missed thing is to forget a dr dt. Okay. You have to also understand what all these variables represent. So dA dt is the rate of change of the area. Dr dt is the rate of change of the radius. And this is all important because you're going to get some things where you're like, the rate of change is 0 because something's not changing. Like it's a fixed cylinder or it's a fixed cone. Something's not changing. Okay. So, now I can plug everything in. My dr dt is 1 foot per second. My r is 4, and I don't know what dA dt is. So dA dt is equal to pi 2 times your r, which is 4 feet, and your dr dt, which is 1 foot per second. Notice that I put in the units because you're going to ask me what are my units that I'm supposed to put down. If you put in the units every single time, you should be able to cancel out units or multiply units straight across. And then you won't ever miss them. So my dA dt is equal to 8 pi feet squared per second. And I do that every time. I put in my units, even though it will get a little bit messy, I will put in my units just to make sure I don't mess up somewhere. Because you do get, sometimes you do get an entire point for units. About 1 point is about 5%. On any given test, 1 point is about 5%. So you don't want to miss it. Okay. Air is being pumped into a spherical balloon at a rate of 4.5 cubic feet per minute. What is the rate of change of the radius when the radius is 2 feet? First of all, I hate decimals, so I will change this into 9/2. I know, all the scientists will die when I say that. I hate decimals, but I do. Okay, my first thing is volume. So volume of a sphere is 4/3 pi r cubed. You're going to ask me, do I need to memorize these? And I'm going to say yes. I don't know what College Board is going to do. Sometimes they're super nice. They've been super nice for the past maybe 10 years. And before that, they were super evil and gave you no formulas whatsoever. I will tell you they for sure will not give you the Pythagorean theorem, and you will need to use it. It's so funny. Only here when I have to tell somebody on the day of the AP Calc test to turn their socks inside out. Only at UHS. Huh? Alright, so let's take the derivative implicitly. So dv dt, which is the rate of change of the volume, is equal to 4/3 pi 3r squared dr dt. I would like to simplify my life a little bit, so 4 times pi times r squared dr dt, so I'll cancel the 3 out. And then I gotta plug in everything. My dv dt is 9/2, so 9/2 feet cubed per minute is equal to 4 pi r squared, so 2 feet squared dr dt. And then I'm solving for dr dt. So 9 feet cubed over 2 minutes is equal to 16 pi feet squared dr dt. So 9 feet cubed over 2 minutes times 1 over 16 pi feet squared is equal to dr dt. And that's the whole reason why I put my units in there, is just so that way I know that my dr dt is supposed to be feet per minute. So this is 9 over 32 pi feet per minute is dr dt. So let's be clear. Pythagorean theorem relates lengths of sides together. Pythagorean theorem relates lengths of sides together. So if I want the rate of change of a side length of a triangle, a right triangle, I'm looking at Pythagorean theorem. Okay. I will ask you the rate of change of a theta with a triangle. I want you to use tangent. We only use tangent. We blame the physicists. Only use tangent, don't use sine or cosine, otherwise you will not get the right answers. Use tangent. And the reason why typically we use tangent is because there are normally whole numbers that you go along the x-axis and whole numbers that you go along the y-axis. You typically don't have square roots, so then you wouldn't have any approximations. And that's why we don't do sine and cosine. Okay. Questions? Alright, you guys have the rest of the class period to work. Find the Pythagorean theorem one and try that one. There's a triangle one in there. Oh yeah.